Hi everyone. Welcome to our first section in calculus on functions. In this section, we're going to review a couple different concepts that will help you to understand functions a little bit better. And I think you'll find this a very helpful presentation as well. So, we want to look at rational and irrational numbers. And a rational number is one that can be written as a finite or infinite repeating decimal. And here's an example of this in two different ways. Now, an irrational number is one that doesn't have or represent an infinite decimal representation, and it has no repeating pattern, like the radical 3. The number line is something that's going to be represented, and a number line will help us represent where numbers are located on this track. And it'll be a geometric representation of all the real numbers that are shown. When we look at open and closed intervals, an open interval is a set of numbers that lie between two different points. So in this example, x has to be greater than 4. So 4, everything greater than that to infinity. A closed interval is when it's looking between two different points. So it's looking between -1 and 4. So x has to be in between -1 and 4. There's an example of showing this on a number line. Now we look at functions in applications. So let's look at this example. When a solution is introduced into a heart muscle of a frog, it diminishes the force with which the muscles contract. The data from experiments of the biologists A.J. Clark are closely approximated by a function of the form r of x, and here's the function, where x is the concentrate of this acetylchlorine, b is a positive constant that depends on the particular frog, and rx is the response of the muscle. So they're looking at this, and this is a great example to help us understand functions. So suppose that b equals 12, you're going to plug this in. So if b equals 20, you're going to put 20 into there. X equals 60, you're going to put x into there and x into there and calculate it. So what would your solution be? After you put that in, your solution is going to be, given this is a given function. You put it in like this, replace b with 20, x with 60. Simplify the numerator and denominator. Divide it. 60 right here. So we look at r equals 75%. So they're going to give you different approximations. So replace x with 50. Replace r of 50 with 60, which is what you got right here. Simplify the numerator, because now we want to solve for b. When we simplify the numerator on both sides, 60b plus 3,000 equals 5,000. 60b equals 2,000. b equals 33.5. So what does that mean? So when r of 50 equals 60, b equals 33.3. So if you look at that and you go back to the function, you can solve any application in these functions is one of the illustrations that we look at. Functions are a very good way to illustrate how the dynamic of problems are set in place. Another example of a function, f of x equals x squared plus 4x plus 3. Find when the function is a minus 2. So how do we solve for that? So this is the given function right here. F of a minus 2, solve for this right here. So anytime you see x, replace it with a minus 2. We do it like this. So let's simplify it. F of a minus 2 equals a squared minus 1, combine like terms. And this is f of a minus 2 equals, there's the result of the function, a squared minus 1. So there's a couple examples of functions and how the role of functions will be in place. We will continue on our journey in various videos with more application of the role of functions.